Yeah.
Perfect. I'll leave you in charge of recording the video then.
Yes. All right.
Um, and if there's anyone who doesn't want to be on a video, please just let us know, and we're gonna edit it, and we can remove anything that you
Yeah.
say. So don't feel like you can't talk just because we're recording. Just let us know like privately after the call, and we'll make sure that we edit out anything that
Yeah.
you say or whatnot.
And same too with like pictures and names as well if you want that
Yeah.
privacy. So
Yep. Okay. So I will introduce myself, and then we'll introduce the program, and then we'll see where everyone's at. So my name's Kyle. I've been programming unprofessionally for about 15 years now. Started with like game development, um, coding private servers and that kind of thing. Moved into like a lot of Unity development, um, a lot of graphics stuff, and then I started programming professionally 7 years ago. I've been mostly working in the finance and insurance industry. Also spent some time in crypto and blockchain stuff. And right now I'm working as a senior at an investment company, and we're actually moving from Python to a like functional programming. Um, we're doing functional programming in C sharp because unfortunately we couldn't get Haskell approved, but that goes into other reasons. But a lot of the skills that we use in Haskell, I've been able to like we would not have been able to do what we're doing in C sharp without these skills. So it's kind of cool to be able to bridge the gap between the functional and object oriented slash imperative world. So that's what I've been doing for the past 6 months now. Um, I started learning Haskell about 2 years ago. Maybe actually it's probably 3 years ago now. Same time, similar time as Galen.
even
We
four
started learning it
years.
together. It's probably 4 years. Yeah,
Yeah.
time flies. Um, and yeah, it's kind of just completely changed the way I think about programming. And we have there's a lot of reasons behind that, and we'll get into all of that. But yeah, just excited to kind of share that. Um, for this program, uh, I'll let Galen speak a little bit more about it as well. But essentially, effectively, what we're trying to do is kind of be your mentors for getting hired. So we're taking a bit of a different approach where a lot of recruiters really focus on quantity, um, like getting a large talent pool and having that talent pool, like trying to get them jobs and basically try to make as much money as they can. We're taking a bit different of approach where we're focusing a bit more on quality. And so what we really need to do to be able to focus on quality is to have a hand in the training or at least in like testing, right? Like anyone can do an online test, anyone can have chat gpt beside them and answer all the questions to an online test. Especially now with ai, it's like how do you actually know that you're getting a good candidate? And so what we're looking to do is kind of build up a community of talent that we actually feel good about, that we actually feel like we can vouch for. Um, and then Lauren on the sales side of things is working on like directly with companies who want quality. And so we don't take anything from you, like no money or anything like that. We get paid when you guys get a job, and we get paid the by the companies themselves.
Mhm.
So our incentive is to help you because obviously we want to get paid, but it's not like you're losing it. If really, if any, like for anything, it's like free for you guys. It's just
Yeah.
just free knowledge at that side of it.
And
Um,
I'll just add on to
but
that,
yeah,
like
Galen, go ahead.
yeah, like because like we noticed there's two different industries. Like we started with ACE interview prep, um, and we're trying to help people get jobs, and we kind of realized that there's two different industries of like recruiting, and then there's like education, and developers are paying for lots of money for education, and then recruiters are being paid quite well to find candidates. And like I've also worked with recruiters in the past to find a job. Kyle, I know you have as well, and it's very basic what they do. And it's always like surprised me honestly what like how much they get paid. Honestly to do nothing. Not nothing. Like they do connect you with like the people, and they do have those connections, which is really the value that they do provide. Um, Amongst other pieces of advice they can give. But we kind of looked at it as like, well, like why don't we just combine these two? We can provide free education to get into software development, and really, this is meant to be for anyone. Like this is why I brought up like that I am not I didn't go to school for computer science, and I think while it does help, we want to provide an avenue for anyone to be able to get into it. And as a kind of funny story, I'm my fiance who has never programmed before. I'm actually going to sort of independently work with her to try and get her a high paying tech job, and so that's like kind of a side project that I'm taking on. Um, but because I believe it's absolutely possible, and especially through something like Haskell, and I think if I look at my own experiences, Haskell has absolutely been the key difference maker in why I've developed so much as a developer. And I think even too, like there's an interesting thing we've noticed amongst senior. I apologize because my camera is broken. I don't know why that is. I have an old computer that might need to get replaced, but um, I noticed there's like like so I'm doing the air quotes sort of thing, but like there's like senior developers air quotes, and then there's like actually senior developers, and what I mean is like there's people who have it on their experience. There's according to their experiences that they've been coding for 7 or 8 years that they are senior developers, and nothing against them. They have definitely earned such a title. But then you ask them a question about maybe a project they're leading, and they aren't really sure how to help you, or there's these sort of like mystical beasts that are these senior engineers that somehow just seem to know everything or somehow seem to know what to do in any case, and that's the kind of senior engineers that we want to train you guys to be is just like a deep understanding of what you are actually doing, and that truly comes through Haskell. Um, and that's why Kyle was talking about like the like sort of ChatGPT and all this. It's not like there's anything wrong with like using ChatGPT, but um, you know, it should be an aid as opposed to a lifeline. Um, so
Yeah.
I
So
think
we'll get into the why Haskell
yeah.
in a bit. But yeah, does anyone like if it'd be great to kind of get just like a quick 1 minute like background from each of you. I don't know if anyone
Yeah,
wants to go first.
maybe even like obviously I guess we could see names, how long you've been coding, what's your like preferred current language,
Yeah,
maybe a fun fact if you will.
Well, I can start.
sure.
Well, my name is obviously Thomas Michel, from France, Paris. Well, as for me, I've been coding professionally since I'm in high school, so about like 8 years, 8 years ago. And well, I decided to study in computer science because that's what I like in general. So I made like a 5-year program. Actually, validated my master yesterday. I got my certificate yesterday. So thank
Heck
you.
yeah.
Yeah, so basically, yeah, I've touched like a lot of different technologies already. Kotlin, TypeScript, Rust, C++, Haskell also a bit during my studies. My favorite one is definitely these days Rust. I want to upgrade my skills in Rust because I just like the language so much. Uh, And yeah, basically that's it for me. I've been working in general. I've done like 5 or 6 internships already during my studies. I've been also working freelance on different projects, usually MVPs for startups. And basically now what I'm looking for also by coming here is getting new opportunities. I'm looking for opportunities in general abroad, like getting this high paid tech jobs in general, because I feel like Paris is good, but I really want to have like this American experience, I feel. So yeah, that's why I'm here today. And also, of course, training about Haskell also, because I mean, it's been a long time I didn't do any Haskell in general, but I really like the language when I was working with it. So maybe like getting
Yeah,
experiences.
that's good.
Yeah,
Love that.
right.
Awesome. Does anyone else want to go next, or should I pick someone randomly? Maybe Eric, or what are you thinking? If not, it's totally fine. We
Yeah.
can just move on as well. But I just want to know where everyone's at if we can.
Yeah. And yeah. No one else has to do introductions. Good to see you, by the way, Hector. So, but
Okay.
yeah.
All
Hello.
right.
Um,
So yeah, if you want to, you can just even add just a quick blurb in the chat while we go. But just based on time, I guess we'll get
totally.
started since we're not having a whole bunch of desire for that. I know everyone's a little shy. That's okay.
Kyle,
Um,
do you want to control the slides, by the way?
yeah, I'm gonna present. So
Okay.
give me a second here.
Fair enough. Hello,
Yeah,
hello.
no worries. Okay, let me share. And feel free to ask questions in the chat while we go.
Yes.
We're gonna try to please ask questions. If we think it's a quick answer, then we'll kind of divert from our current conversation and do that. But we are going to try to get through the material that we have, and then we'll definitely answer all these questions at the end. So where's the share option? What the heck? 1 second. This isn't working very well.
If needed, I can just Google
It's
slides, right?
Yeah, it's for some reason not. Wait, this oh wait. I got it. The little pop-up menu doesn't show
Yeah.
the share option. I have to go back to the screen.
Gotcha. All right.
Okay.
So I believe I'm doing number one, and then you're number
Yeah.
two.
Yeah, you can get started.
Okay. Um, but before going to the next slide, I'll say next slide. We probably should have coordinated this little piece or whatever, but yeah. Anyways, so in terms of like why learn functional programming, the next slides that we have like sort of get into they get like technical in terms of like explaining why the language is like so well written. But I want to like before even getting into that talk about like sort of like the experiential aspects of like why do I like specifically enjoy like using Haskell so much. Like when I'm using like Golang, Rust ain't bad. I do like Rust, I will say. But you know, if I'm using if I'm using like Golang, JavaScript, TypeScript, I am markedly much more unhappy because you know I just know what could be if I was writing this in Haskell. Um, and so the reasons for this that's why we want to teach you guys this is like the experience of writing Haskell is amazing, as well as like what we talked about with like it's going to make you into a better programmer and just in terms of the way that you think and analyze code. And even like if you like let's say we're to be coding together in a repo, you would know like which code is my code versus which is someone else's code because it looks Haskell like. Even if it's like TypeScript, I'm coding as much as I can like Haskell, and knowing the caveats that I have to kind of look out for, and mentally think about, that would be normally handled by Haskell. And so something that like Kyle and I's mentor talked about a lot is this like psychological idea of like you have like I think 7 things in working memory that you can hold at one time, and when you're looking at like a normal JavaScript function, there's just a lot going on, and there's a huge scope of that function that you have to understand, like what exactly is going on, as well as there could be some sort of code elsewhere in the code, in the repository, which is going to have an effect on the way that this code runs. So it could depend on some global state, and you don't know the current state of that global state, and that will impact the way that this function runs. And so that makes it much harder to think about and reason about the code and say, is this correct, or can this fail easily? Right, because it's not like we're asking like what's 2 plus 2. We're asking like how does addition work. We're asking how like these complicated functions work, where there's already so much going on. Like there's already so many different inputs that we have to consider, and we want to make sure that each of those inputs is handled properly. And now in theory, you could like reach the same results with another language, but like Haskell just simply helps you to do that a whole lot better. And it even through the learning of Haskell and through like the errors that you will come across with Haskell, that you'll learn why those errors are there. It again just helps you to deeply think about how you should write code in general. And of course, this is not going to be the case, but at least for some time until everyone is like very comfortable with Haskell. But I like am weird in that I genuinely prefer reading Haskell code, as opposed to documentation. Like I literally learned HTTP, and how HTTP works through the Haskell HTTP library, because it's such a well organized set of types that I could literally just say like, oh, like okay, here's how you organize any sort of HTTP request. Here's the sort of cases you can do, and in order to provide a manager type, which is going to help me with running it or whatever, I need to do these steps, and you can kind of clearly see that from the type signatures. But yeah, that said, until you guys are like much more comfortable with Haskell, kind of like honestly have some faith with us that we're not just wasting your time here and just obsessed with one language over the other. This isn't like a Python versus JavaScript thing. Even before I learned Haskell, I was like, all these languages are like roughly the same. I don't really see what is actually the difference here, and I've very much changed my opinion on that. So, if you could pop to the next slide there.
Give me a second.
Yep.
So yeah, I'll take over here. So the question, like oftentimes you hear about, why learn functional programming? Everyone says that a lot of people say it's better, a lot of people say it's like harder, etc. A lot of people say, why not just use Python and TypeScript? Python and TypeScript have functional programming libraries, right? And so what we're really trying to focus on specifically with this, I mean, we could give 1,000 reasons, but I'd say like the biggest reason why is that these languages are dynamically typed as opposed to statically typed. So what that means is that you don't know at compile time. So like when you first compile the application, you don't know how it's going to run. You can like try, like you can, but at the end of the day, like we're humans and you're going to miss something. Like whether you miss it, whether someone on your team misses it, whether like, because programming in a box is really easy. If it's just you programming, I would argue that it's like maybe 100 times easier than programming with someone else. And in any real job scenario, you're going to be working with multiple developers, right? And so how do you, as a unit, ensure that you're not just introducing bugs in edge cases into your code? Python and TypeScript traditionally have a lot of troubles doing this. A lot of the way that it's done nowadays is to essentially just write like 100% coverage-based test. Like you might have heard of coverage-based unit testing, which is where you're basically just making sure that every function that you have, every line through every function that you have has a test written for it. The problem with this is you're just writing your code twice and you're introducing the same bugs twice. So like if you're writing a function and then you're writing the test for that function, you're just reinforcing your own assumptions. And so the only other way to get around that is, for example, to have someone else write a test for your code, but this never happens. It's also extremely inefficient because now that person has to learn how your code works. Everyone writes TypeScript and Python differently, and you're running into a bunch of problems at runtime. Anyone who's worked in a professional setting probably knows how often you're debugging and writing tests. We know how something worked yesterday and now it's not working because a change was made. These are very common issues, and the industry has kind of normalized themselves to these issues. But what we're about to show you is kind of a way to avoid them entirely. And so I've got a couple points here on specifically why you might want to avoid Python or TypeScript for functional programming. And sorry, Galen, what were you going to say?
Yeah. I just had an idea, sort of a random, unplanned idea, but like, since we're talking about like experiences with like Python or TypeScript and like sort of chaos, does anyone have? And no problem if no one wants to speak up here, but like, does anyone have like experiences like that where they've been like really frustrated by their code or really
Or maybe
frustrated
you
working with?
wrote some code and someone else changed it and all of a sudden it broke, or someone else added something and then it broke. If you do, put them in the chat.
Yeah,
We'll
fair.
definitely we'll get to it.
Yeah.
But that's a good point. Is like, and if you haven't experienced this a whole lot, I tip my hat to you because you're very lucky. But basically I guess the reasons why, like, so I guess the question then comes up again of why are we teaching you Haskell? Functional programming in its essence, essentially what we're doing is we are, rather than mutating state, we are chaining together functions. So this means that every input and every output is known when you're actually using the function. There's no magic going on. There's nothing that can change between the time that you're using it and what you're not. So even if you have, say, like a Python or a TypeScript library, the number one problem is that purity is not enforced. And so a pure function is a function where it has no side effects, meaning when you call it, if I call this function at 10 o'clock today, or if I call it at 12 o'clock tomorrow, if I give it a 5, it's going to give me a 10. It's a very simple example. But this basically means that like we're not writing functions that are changing some cache of state, or we're not writing functions that go and talk to the database randomly, get a value from the database, and these kinds of things. And the reason why this matters is because pure functional programming relies on functions that have no side effects, and this ensures that it ensures that our behavior is predictable and reliable. So without this, like you might have heard of the term race condition. This happens a lot in programs that have any kind of concurrency. Pure functional programs avoid race conditions entirely. So that's like, whoa, how can we even really yeah. What's up, Galen?
Oh, sorry. I just wanted to add like another point, or like say it in a different way too. Like, um, because I know that a lot of what we're talking about is like very hard to understand if you haven't like seen it before or talked about these sort of things before. But like, you can almost like in a I like to think of things visually, and like if you have like impure functions all over your code base, what you effectively have is like a spider web or like a graph. A graph is a more technical term, but you can think of it as like a spider web where like any different piece of that spider web is connected in some way to another piece of that spider web. And that's like maybe you've written better code, or maybe the code is better, and that's not the case. It's actually a little bit more organized. It's like a very clean spider web, but or even like the nature of the spider web is well known. Like it's very symmetrical or something like that. Whereas like Haskell would just be like a pitchfork almost in terms of the connections, where it's like and why I say a pitchfork is like if you think about like the three prongs, you would predictably know that the each of the prongs feeds into the end of the pitchfork, and so it's like a much simpler sort of like flow of how the behavior of the program is working. Yeah.
Yeah, that's a good. Yeah, and that only happens when purity is enforced. And so when I say enforced, I mean the compiler literally does not allow us to write immutable functions. Like you can't, unless you specifically allow. And if you've used Rust, Rust is just a fun fact. Rust is written in OCaml, which OCaml is a pure functional programming language. So the reason why Rust is so good is because it was literally written by a functional programming language similar to Haskell. So fun fact. And so in Rust, for example, everything is immutable, and you have to either copy the value or you have to specify mute, the MUT, and oftentimes it's discouraged to use mute. It's very similar in Haskell. Everything is completely pure. You're not allowed to change a value. You're only allowed to create a new value. And this takes a little bit of time to get used to at first, I will admit. But when you really understand why this happens, it's probably the most powerful feature of a programming language. And when we talk about a programming language, like really the language is only as good as the compiler, right? So if a compiler lets you make a shortcut, those shortcuts are going to happen. Like it's going to happen. You're going to have somebody on the business side at your company that says, how long is this going to take? Oh, it's going to take 2 days. And they say, well, we need it done in 1 day. And so are you really going to be like, if you're on a tight time constraint, and the language not only allows you to take shortcuts, but makes not taking shortcuts harder. It's like if you had to go over a mountain, or you could just like flow down a river, which one are you going to take? Well, the river might take you off of a waterfall, but like whatever, we can worry about that later, right? So that's kind of the concept here behind enforcing purity, is that we're forcing ourselves to program properly, and conversely, from a teaching perspective, it allows us to really get an understanding of like do you actually understand what you're doing, or are you just kind of making it work for now? And so purity will essentially force you to I call it compiler chess, because it's like for your first couple weeks of using Haskell, even months, you're going to just be getting error after error after error after error in Haskell. And this is completely normal. This is actually the best feature of Haskell, is that it tells you when things are wrong before you would have found it in runtime. So everything's moved to before the client sees it.
And we're here to help.
Yeah, and we're here to help. So if any of those errors are confusing, you can definitely reach out. The second point is that immutability is not enforced. I talked a little bit about this. It kind of goes hand in hand with pureness, But yeah, this basically Python and TypeScript both allow you to mutate state by default. In fact, like almost every library that you use uh, will do this. And so it's like, how do you how do you get around, like even if you were to try doing functional programming in TypeScript, like you if you're using a library that has mutations in it, then you're just back at square one. You're not actually doing functional programming. So that's kind of an important distinction there. Um, Types in TypeScript and even though TypeScript is called TypeScript, it's not like types aren't actually fun. So as you learn through learning Haskell, you'll see that types are actually values themselves. And so what this does is it allows us to encode constraints and business logic directly into the types themselves. So rather than having like a simple type and then you have all these validation functions everywhere, we can actually enforce all of these rules into the type. And so we'll get into like a concept called smart constructors. We'll get into pattern matching, all these kinds of higher kind of types, all these terms that you might not be familiar with. But they effectively allow us to do everything at compile time rather than at runtime. So rather than writing complex tests, you're just going to write functions and create new types. So the amount of test code that you have to write in a functional programming is much less, and it's much more reusable. And then finally, there's no compile time safety in these languages. So, you'll get unpredictable bugs. You got to write a ton of test cases. A lot of times you have to write what are called mocks. So you're mocking. You're basically like creating test data structures that feed into your functions. And if you mess up something on that, then you're not catching all of the error conditions, as well as like mocks are just very laborious to update. Like if anyone's had to write test code suites, like the moment some data structure changes in your code, you've now got to update all your mocks. You got to rewrite your tests. It's just like a lot of this testing can be done by the compiler, and then we can focus on the actual like when you're writing tests, oftentimes you're writing tests just to test that the code that you wrote doesn't break. With Haskell and with functional programming, we don't write those tests. We know that our code won't break. The only tests that we write are ones that ensure that it does the right thing, right? So we want to know that some effect actually happens. You can almost just call it like we're just testing the happy path. The exception path we know will be handled. We just want to make sure that like when we click this button, this thing pops up or this thing happens. And so that's really what it comes down to with compile time safety.
And I'll even
And
say,
go ahead.
yeah, like, and my role here just being to like what was like the simplest example to kind of like add here is like because I still think this is crazy that like in Python you can have a name error come up at runtime. I can't imagine like having that. Like it seems so funny that this is like a thing. For example, like I had a web scraper that worked fine for like 3 months, and then a particular case fired. Um, and in that particular case, I did not set a name. Let's call it X, and like the program failed because of the no or the name not found error. And like whereas Haskell, it would so easily tell you like I don't know what this name is that you're referring to. Like please fix this, and which is nice. Like it's not. I don't even think of it like we think of like errors as being such a bad thing or whatever, but like that's actually like a helpful suggestion more than anything. Like if this function doesn't know what a name is, you want to make sure that you handle it while it's still fresh in your mind, because if I see this immediately, I'm gonna say, oh, duh, yeah, I didn't import that, or
Yeah.
something like that. And then even same too, like a lot of the errors that you actually get or with like other languages are like type errors, where at runtime it's trying to convert a is trying to coerce from one type, or sorry, like change from one type to another, and saying like this doesn't make sense, or even worse, it doesn't realize that it shouldn't change the type in that way, and you end up having JavaScript, doing addition, saying one plus an object. Like you're literally trying to do addition with like one, like an integer and a class. Like you can literally, and what you'll have is that you'll see like string addition, which is not what you meant to do, but you just had a bug in your code that you didn't realize. So
Yeah. So in Haskell, basically errors are your friend.
yeah,
Um, a lot of languages, they're kind of seen as like, oh, you've got errors, this is bad. Um, but no, they're very much your friend, and you want error. Like, think about it this way: would you rather have an error before you ship the product to your client or after? Right? Like it seems pretty obvious. You want the error before your client sees it. Um, and so by specifically coding using this type system, and you might be a little wary of like, oh, is this even possible? And this is where we say like it is impossible to teach you Haskell in 1 hour. Okay. So we're trying to kind of just demystify, trying to give you like reasons why you might want to even learn it. But as you go, you're going to start having these like aha moments where you're like, that would have been an error during production, or that this allows me to make sure that I know that every edge case is handled, and that's what we're really here to showcase. But yes, you're not going to learn it in an hour, but we're here to help you. So okay, so that was kind of a bit of a rundown on why we're choosing to use Haskell for this program. If you have any questions, please ask, because we want to refine this process. And we actually also have. I'm sharing the tab, so I'm going to switch over to. Now we've been adding this to the ACE website. I don't think I'll just show. So if you've been on this is a work in progress. So we're very actively developing this. This whole like system is new. But what we're actually looking to do is to have all of these learning materials hosted on the website. And so you will have a
it would have opened up
set
in
up
a
project
new.
review.
It would open
Pardon?
in a new tab.
Oh yeah, you're right. It's a new tab, which is good. But let me
Yeah.
share that tab. So when you click on that, it opens up a new tab. I was scrolling through that tab without you guys knowing. Give me a second here.
That's my job, is to be
Yes, make sure we're on track here.
yes.
Okay.
And by the way, if you have a question, like, it's probably on us that we haven't explained things in the best possible way,
Yeah.
and more likely than not, you're one of 5 people that has the same question.
hmm
So
Agreed. So everything you need is here. We've been putting together a tutorial. We've got the first 3 chapters, I think, done. Oh, this hasn't been pushed, but it's done. So we'll get that updated. But basically, you can find everything that you need here. And what we're going to kind of focus on right now is the environment setup. So has everyone here worked, or I guess, has anyone not worked with a Linux environment before? You can raise your hand with the chat if you haven't.
I think this even. Oh,
Okay, so we do have some that haven't. So we do have this guide here on how to use a Linux terminal. So everything, and we'll give you the links to all of this later, or after this meeting. But everything should be here to get you started. If you're on a Windows machine, you can use Linux with Windows Subsystem for Linux. So there's a really good guide here on how to do it. You can also you could set up a virtual machine, or you could just straight up dual boot into Ubuntu. But definitely the easiest solution is going to be to set up the Windows Subsystem for Linux.
and if you are, like, we have had people before set up like Stack on Windows. If you want to, if you want to use Windows, we just don't
Right.
recommend it because a lot of the documentation like we're trying to keep it focused on Linux just because Linux is a lot easier to use as a developer.
Hmm. Yep.
So
Yeah, and so the first thing you'll do, I've got this set up on my machine right now, so I'm not gonna go through it just because it can take like a couple minutes to install and everything. But everything that you need is here. Like we've outlined it exactly how you need it. And so basically, I will do these second steps here, and I'll show you how easy it is to get started with a Haskell application. But the very first thing we're using, Galen mentioned Stack. Stack is a package manager, but Nix is a more powerful package manager, and you'll notice that but Nix is basically like Docker plus, it's like Docker and npm mixed together, but then also like a lot safer, so it manages all of your package versions and everything for you, or not. It makes sure that it doesn't manage it for you. You have to do that work, but it makes sure that they all work together. So there's different derivations and everything that are tested online.
and two, like the main reason we're using Nix is because that way we can pass you a file and say run this and you should be good to go.
Yeah, it'll
Um,
work.
yeah.
Yeah,
So like
it's basic. It abstracts away your environment, so you don't have to actually worry about it yourself.
yeah.
Um,
And if you ever do have like an issue where like your environment is like you're having trouble with setting up your environment, like please let us know because that's kind of like number one priority for us. We want to
yeah,
set it up so that you guys can literally just say like, environment start and like it's just good to go and
start
you
good to go.
can focus on learning Haskell. Um,
So this is what we're gonna do. I'm gonna do this live here. So the very first thing we're gonna do, I'm just gonna create some temp ace, some folder here. Um, and so if you were just follow, like if you do these two steps here, then you're good. Um, next thing is just to create a folder for your project. So we'll just say my Haskell project, and we'll cd into my Haskell project. And then what we're gonna do is we need to create a shell.nix. I use Emacs. You can use whatever you want, but I am going to just do this for the time being. Hopefully it works with no window mode. Yes, okay. So I'm going to just create a file called shell.nix. And I'm not going to type all this. I'll just copy it in. Oh, shoot. Oh, yeah, it's because it's in a terminal. So there we go. So just a quick explanation of this. We're just importing a list of packages from Nix packages. This is just an online repository of where all the actual packages that you like, or libraries that you'll use. And then we're just creating a shell with two build inputs, one for Haskell packages.ghc. GHC is the Glasgow Haskell compiler. So this is the actual compiler itself. And then Cabal install is the build tool to actually go and build, to put a bunch of files together into something that GHC can run. So we do that, and that's all we need to do. And now we just run Nix shell, and this should boot us up into an environment that has everything we need to write Haskell. It shouldn't take too long, I hope. So this is where we talk about, it's kind of like Docker. Everything's hashed and inside of this Nix store. And so you're able to, like, if I give you a shell.nix file, it should work the exact same on my computer as it does on yours. So now we want to use GHCI. So GHCI is the interactive version of GHC. It's called a REPL, read, evaluate, print loop. If you've never worked with a REPL before, they're probably the coolest thing ever in programming, like just in a nerdy way. It allows you to write code and test code without actually having a function, like without actually creating a file or doing anything like that. And you can just get like immediate feedback. You can also load your own modules in here and test those modules, which Galen will show you in the demo. But just as a quick example of like some things that we can do in GHCI, like we can just say, okay, what's 5 plus 5? It's 10. Let's say we've got, like I can do, so there's anytime that you want to interact with GHC, there's the dash or the colon, and I think, is it colon
To do which?
help to view all of them. Is it help?
I think so.
Yeah, yeah. So colon help. Sorry, my dog is barking. You might hear her. It's fine.
She's very cute, by the way.
Yeah. So this will give you kind of, you can read through all of these here. I've kind of shown the main ones that you'll use right here for loading a Haskell file, reloading a Haskell file, checking the type of an expression, getting more information about a function, etc. So like, for example, I can say, what's the type of test? It tells me it's a string. Fantastic. What's the type of, can I do, I'm just going to put it in parentheses just to avoid.
You don't necessarily need the parentheses, but
Yeah. You know, I could say, okay, what's the type of this function? And so this is what gets us into functional programming, is that our functions themselves have types, and these types can be treated as values inside of our language. So this is like extremely powerful. Galen will show you in just a minute. And I realize we are hitting our 1 hour mark. We're totally cool to go over. If you do have to drop, totally fine.
we have the recording too.
We'll send you the recording after, but this, we're kind of going to get into the meat and potatoes here now.
Yeah.
So, you know, this, I'm going to let kind of Galen go on to the next thing, but this like you're already set up to get coding here. Like if I just create a main.hs, I copy this into here. This is like a very simple Haskell program, and I don't have syntax highlighting right now just because it's in here. But don't worry, you'll have syntax highlighting. Then what I can do is I can load this file into GHCI. It'll tell me, okay, one module loaded. This is your, when you see this, you should be very happy because it means that you've won compiler chess. I like to call it compiler chess because when you have errors, you're just going to be going back and forth, and eventually you're going to win if you just keep solving the errors. You will eventually get to this point,
And you'll have an amazing program in the process.
and your code will be awesome. But so when you see this, be very happy.
True. True
Yeah, go ahead.
story. As a like a little interlude or whatever. I'm a little bit irreverent with like playing the compiler chess. There's a web scraping library developed in Haskell, and I just like wrote a bunch of like pseudocode, and like an absolute metric heck ton of pseudocode, and then I just played compiler chess until it compiled, and then
Yep.
it actually just worked.
And then it works perfectly.
So
because everything is accounted for at compile time rather than runtime. It's not like you write some code and then you run your application and you're like trying to figure out like, oh, does it work if I click this? Does it work if I click that? Like the answer is yes. And you'll sort of experience that as you go. So to interact with this, I can just type the name of the function. It's going to ask me, what's your name? I'm going to say Kyle, and then it's going to say, hello, Kyle. So that's a very, very simple program. You can see it's technically 3 lines of code. Actually, this is just a type signature. So it's 3 lines of code. We put the name, we get a line from the console, assign it to the name variable, and then we say hello name. So that's all this program does. Very simple. But this gets you up and running with Haskell. Like you can write more functions in here, right? You can do whatever you want. So this should be everything that you need to actually get started. And I'm going to hand it off to Galen now to do an actual demo
go
ahead.
There's also the Hugel aspect.
Oh yes, you go first. Yeah, go through that first. So let me go back to the.
Thank you, Hector. Cool. So I'll share screen now. Take over from Kyle. Uh, just do entire screen. Everyone can see my screen now. Don't speak all at once. Uh, okay, so this is Hoogle. So this is like your kind of go-to docs for Haskell, and we wanted to show you this quickly because there's like the sort of obvious basic things you might think you'd be able to do with it, but yeah. So like let's say I want to look for like a particular package. Like I want to look for the base package, which is it comes like with any Haskell program. Like the program that Kyle was writing a second ago would have base included. If you look in the Cabal file, you'll actually see this. I could even show this really quick. Um,
Yep. And so basically, it's kind of Google. This is Google, but for Haskell. So you're gonna find every single function that exists in the Haskell namespace. You can even, fun fact, you can even have your own code get loaded into your own instance of Google.
yeah.
Which we'll show you at some point in the future. But it's a great documentation tool. You might have worked with like Swagger or like there's a bunch of these,
Yeah.
but I would say this is like probably the best that I've ever seen, and Galen will kind of show you why with
Yeah.
like some of the searching capabilities.
Even too, I actually just for fun opened up my own local running,
there you go.
and I have some of my packages that I've made. So I have like Clash. This is a package that I've made, and I can search through my functions. Like this is just a random function that builds it basically builds CSS in a type safe way. That function looks a little bit confusing, but like for example, I have like
Yeah, we'll get there.
TW size, yeah. So I can just search sort of anything. This is just models like Tailwind basically, but this is like the like basic Hoogle that you guys would be able to work with. Like you don't really need to run your own. That's just more like for Ace coding and or repo, it makes it a little bit easier to have your own Hoogle instance. So now, so I've shown you how to like look for a package. What about like if I want to look for like a particular module? Like if I was to in my terminal, let's say can I do GHCI, and I use Kyle's I call help. I see that I can look for information about a function. I know that the command is :I, and so I want to learn more about string. Oh, what did I just do?
Also, can everyone see? Maybe Galen, if you want to can you make the text size a little bit bigger?
Totally. I'm strange in that way.
Galen has very good eyes. He uses like size 8 font.
I'll you know what, I'll do that even now for this one too.
And drag it over too, because it's a bit squished.
Yeah. Okay. Yeah.
You can set it back after.
Oh, totally. Well, yeah. Yeah.
Right.
So I've used information to learn more about string because I was looking at Kyle's code, and I went what is string, or what is IO, even. I saw this like IO thing. I don't know if that will work. Interesting. And I wanted to learn more about it. This will like give me more information, and I might get to a point where I'm like, whoa, what is all this stuff? And like I want to pick some random thing here. I want to pick read or show. This is actually a better one. What is show? Like, and I'm kind of getting sick of this like little :I, so I can type in here show, and I'll find show is provided by all these packages, particularly base in the module prelude. My alarm was going off. And I can learn more and find documentation on how show works. And I can see from reading all this that what this does is it just allows me to show show something as a string, or turn a value into a string. So I have an integer 1, and I'm going to return it into a string. Cool. what's also and I can even and I can look for any type in here, right? Like I can also look for string. I can see that string is a type. We'll learn more about that in future. Um, I can see it's from the Prelude module in the base package, and here's how string is defined, and I can read more about it. What's also really cool is like let's say and this is kind of getting more advanced with Haskell, sorry with Hoogle, but like really cool and not too hard to understand. I don't think. Let's say like I know I want to find an element in a list, and um, yeah, I want to find an element in a list, and like I have an idea. I know my Haskell well, and I'm like, what would that look like? What would the type signature of this list be? And it'd probably be something like, it'd be a function, which I'm going to write this like it's like JavaScript or whatever. It's a function which takes an index and takes a list. And I know that in Haskell, this kind of looks like a function which takes an index and a list, and this is pseudocode, by the way, not real Haskell here, um, and it's going to return something. I guess in JavaScript, this would be it returns a num or like an integer, and so I want this to return an int. Can I look for something like that? Um, Sorry, pardon me. Um, Sorry, I thought I was gonna sneeze there. I'm having a bit of allergies today, but I can look for functions based on their type signature. I can even like look for something that like, for example, returns a string, takes something and returns a string, um, and I will get like results based on that. And I don't recommend like using that off the bat, but I think that's like a cool feature of Haskell that you can like that because of the type system, we have sort of like a language that we can communicate on and like look for particular things. Um, so
Yeah,
um,
yeah, I think that's good.
yeah,
I think that's good for Hoogle. So
cool.
everything you need to find can be on Hoogle.
Yeah,
There's also something called Hackage, but we'll get into that at a later time. That's where you find all your packages and stuff. But we're not going to be working with packages right now.
yeah.
Just going
So
to be writing code out of the base package.
yeah. So now, and Kyle, could you like sort of direct me through since I'm recording my screen? I don't want to flip back and forth too much.
Yep.
Could you tell
Yeah, I'll
me?
give you the.
Yeah,
I'll tell you what to do.
Yeah.
Yeah.
Thanks, boss man.
Okay. Yeah. So the example that we're going to provide right now is imagine you're creating a store. So you want to uh, this store is gonna sell t-shirts, we're gonna sell pants, and we're gonna sell shoes. So we got three different product types. Each of these products have different features, right? Different different types of information. I'm just getting up this. We wrote down some notes on this to
Yeah, it
make
should
this
be in
go a
the
bit smoother.
Discord.
Yeah, yeah. And so, very first thing we want to do is we want to basically just model like credit card information. That'll be the first thing we do.
Yeah.
So, Galen, do you want to show us how you would model credit card information?
Sure. So, I'm not 100% sure this is the same everywhere in the world, but I know, I think it is though.
At
Um,
least in the U.S.
yeah. So a credit card has a card number, 16 digits, a expiry date. On my card, I think it's like, I think if I'm just thinking about um, my card in particular, I think it's like if I read it off of my like physical card, I think this is the format, month, two digits for month, a slash, and then year. Um, and then we have a security code, or I think it like called like a number of different things, like a CV code or something like that. And this is 3 digits. Um, so three numbers. Like so for example, you could have 123. For here, we could have 123, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Here we could have, as an example, 06, 29. Hopefully, I haven't exposed anyone's credit card information, but very unlikely. And so again, like with this next example, like, try to like not like overwhelm yourself, like because this is a definitely an experiment of how we're teaching you guys right now. I'll be honest. And like there's a lot that's gone into like how we're thinking about doing this experiment, and we do think it's the right way to go, but like Kyle said, you're not going to learn functional programming in 1 hour. So all we're really trying to do is show you like how nice it is to work with functional programming here, um, and how easy it is, like how easy it will be for me, someone who is comfortable with Haskell. And I'm by no means like the greatest Haskeller in the world, but I'm definitely comfortable with Haskell, and something like this is like easy to do. Even as Kyle is going to be a greedy customer and ask for more and more things out of our application. Um, so the first thing I'm going to do is I'm going to use this do syntax. I will actually. I'm not even going to start with that because I don't know how I would tackle this as a whole, and I don't need to. But the first thing I want to do is I am going to need a parsing library. So I know that the module name is parsec. Is this
You
going
might
to?
have used regex before. Just a side point. You might have used something called regex for regular expressions. Um, in functional programming, we try not to use regex because it's not declarative, meaning it can provide different values based on different, and it's really complex. So we use what's called parser combinators. So if you want to learn more about what parsec is, it's a parser combinator, and we'll show you why it's so powerful throughout this.
Yeah, and like it ultimately just allows us to read in a string, right? Like we could have a string like this where it's like 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 0629, 1, 2, 3, and we can turn this into an actual type safe card that we know is valid, and we know we can do transactions with. We don't, we know that we're not going to um, have some failure with processing the credit card and then end up not. Maybe the customer gets stuff for free, which is not the worst thing in the world, but we definitely don't want, and the business people don't want. Um, so all I've done is I've added parsec to my project. So I'm just going to close that, and I'm going to check that this works. Cool. And now, like, now that I have parsec installed, I am just going to break this down into its constituent parts to think about, and I'm going to be able to ensure that I can write this. I just want to start with this because this looks like the easiest thing to do. Um, I am going to look for a function. I believe it's called digit. Yeah, so I have this digit function, um, and this allows me to parse a singular digit. So I'm going to say, I'm going to call this, I think it's called CVC here. So I'm going to call this CVC. My type signature is going to look something like this. Why's my brain not working? Actually, sorry. It's just going to look like this. I'm going to ultimately have a list of int here, and I'm going to start by saying I want a digit, and this is going to parse a singular digit for wherever I use this parser. And so I'm just assuming that my parser is at this point. Um, and I want to parse multiple digits. I know that I want to count 3 digits, so I'm going to say count parsec. There we are. So count parses some number of these parsers. So I have my my digit parser, and I want to parse it 3 times. So I'm going to say count 3 digit, and this is actually already done. This properly, so this should compile. I'll just do this for the sake of it. Oh, but yeah, technically this is a character, not a. Right. Just plain type chess here. Stream SM card. Yeah, an extension. You know what? I'm gonna avoid that. I'm just gonna say. I know that. So this is what I'm working with is a higher kind of type, which we'll explain at a later date. But just basically, it allows me to write code that works with a number of different like cases. I could use a string here, or I could use a different like a string like type. Like there's similar types to a string, like for example text, byte string, and others that I could use, and I wouldn't need to change anything about this code. I could write this code, and count 3 digit would work for that as well. Yes. I'm gonna say IO.
Yeah, and just quickly, like, because if you've never seen Haskell before, this might seem really confusing. So after the type signature, the lowercase letters, those are polymorphic types. So it means that it can be anything. When we use these uppercase words like string, IO, we're actually like putting the types in place of those placeholders. And so what we're doing is we're removing abstraction. So what he was saying is, you could have parsec t lowercase s. That just means that we need to add a constraint to s to make sure that s can be some kind of string.
Yeah.
So what he's doing right now is just defining the actual type that it will be, and he's making the function less abstract and just making it for strings, not for byte strings or for text.
Right. Like for example, I could say here, like I can manually specify that it's text, or I can manually specify that it's string, or I could say I want it to work for both, and let me call this string like. It just has to be lowercase, and I could have like I could have this sort of thing where it's like stream like. And it will work. This would actually be like that, but yeah, it's just there's ways in Haskell to make your code more reusable effectively.
Yeah.
And so we'll get into how to do that, but we don't need to do that right now. So next I want the expiry date. So based on logic here, I know that the expiry date is probably going to be roughly the same, except I gotta specify. So all this means really, and you know what? I'm gonna use a type to simplify things that we don't care about. I'm gonna say my type is my parser. Yeah, my parser wrapper, or that's a lot. my parser equals parsec t string io. And all this means is that I'm just now able to turn this into my parser. And I'm actually I don't like that name, so I'm just gonna call it like parsec with the two C's to avoid a name issue. Parsec, because we don't really care about that. Like we're not trying to do anything abstract or crazy here. So all this means is that in the context, wrapped in this parsec, I have character, which is similar but different from a list of characters. Um, and we'll learn why that is at a later date. But ultimately, for now, you can just think of this as I have a list of characters, and a list of characters is a string. Um, so I can actually even if I wanted to, I could say this is a string. But I'm just going to not do that for now. Kyle, keep an eye on the questions if they do come up. I can't see them.
Yep.
Because
Yeah, it's all good. Oh, we're good so far.
And this one is just going to be, I'm going to keep it very simple and naive. So I'm going to say count 4-digit. That works. And also too, the way that I'm allowed to go about this is I'm able to just think about like, how do I work with just this? Like this code that expiry date, this expiry date function that I just wrote, works with this 0629, and it doesn't care what is happening over here, and it doesn't care what's happening over here. And because I can think about that later. Oh wait, I just realized too, I'm missing. And even I'm gonna keep things simple for now. Oh. The last thing I have is my card number. And this is a parsec card number count 16 digit. And this should compile. I'm not using these functions yet. But yeah. So now let's say let's treat this like it's like a bash function. So like how I'm running Cabal is a bash function, and that I can pass command line arguments to it. And so I'm gonna like fake this a bit just for the sake of simplicity and time. I'm gonna not do that. I'm gonna say input is get line. And so I'll show you what this does here. I'm just gonna print out input. So if I say Cabal run, I didn't really. This is a very non-user friendly program, but if I say hey hey, it's gonna tell me back hey hey. And I can, of course, do some fun things with that. I'll omit for time. But now I can run these parsers on this input. And so when I say that I want it to look like a bash function, I would like it to be like myStore. Where myStore would have like a help command, but of course that's not found. So I wanted to start by parsing out myStore. So let's just call this like exe, and this is also a parsec string. And exe is just going to be very simple. I'm going to use the function string, which is just going to look for exactly what I give it. I think this is. I like to think this is at least straightforward. The type signature is not. of course, yet, but really, this is just string is a function that takes a string and gives it back as a parsec. And so what this means, it's not like just what this means is it's going to look for the string and give me back a string wrapped in my parsec. And we'll see why I say wrapped or whatever. And this wrapped thing that we have, this parsec, is just going to allow us to do like control flow with these different functions, and sort of tie them all together in a very type safe, neat way that I know is actually going to work properly no matter what. And at the end of this, I'll challenge you guys to try and break the parser. Give me some input that should make it fail. Yeah. So, anyways, all I have to do is I just have to say myStore because I want it to be like that. So that's that. So myStore, and for some reason, so the input's going to look like this. It's going to say myStore, and we're not even going to be buying anything. Like we're going to have what we're buying here, later. But for now, it's just going to take my credit card and charge me. So if I do, you know what? I'll add. That's there. Start. Okay, great. And I'm just gonna say, myStore. But I'm not even parsing or checking that I'm doing anything yet with it. I could say myStore, my story. Now I just want. So I'm gonna start by actually running this parser. So to run a parsec, right? To run something that is wrapped in this parsec, I'm going to need the function parse. Where is it here? I think I can. Yeah, I should be able to run this. So parse. Let me just. Yeah, I'll say case parse. My parser. So exe. So exe is my parser. Source name is just like what I'm calling it. So I'm gonna say bash input. And the actual thing that I am parsing is my input that I'm getting from getLine. So the same thing that we are reading in and printing out, I am going to parse. So for now, I'm just going to, no matter what this does, I'm going to print it. So I'm just going to say print A. And I think this should work. No. Oh, okay. Ignore this for now. This just, yeah, not super necessary. I guess I could have. Oh, so identity is just a type that ultimately, when you see identity, by the way, it just means that like, just make this like weaker, make this less generic, or yeah. We really don't need to care much about identity. It'll make honestly more sense in terms of as you go along, like where you would want to use identity. It's not much to think about. Not worth thinking at all. And let me see if I do 3. Okay, so we have our first program output. I typed in some random crap, and I typed in 3 and it's expecting myStore. Now what happens if I type in myStore and it says I got it right? So now I want to pattern match on this. So I have this. I see then it gives me this type either. And either is going to give me two cases, left and right. Left means I got an error. So I got some error. What am I going to do with that? And I got right output. What do I want to do with that? So I'm going to say print got error. I think that should work. Except I got to do something here, and I'm just going to say success. So I'm just going to print a string to the terminal, and I want to also print my output. My output, I mean, right now, actually, it is just a string. But let's say I want to make this more generic, because I'm going to have a card at some point. So I want to print out what the card was. So I'm going to say show, which turns whatever the type of output is into a string, and then I can concatenate it. And I think that should work. Parse error. I'm going to do the same with this, because I don't know what a parse error is exactly. It's a more specific, well, I do know what it is, but it's a more specific type than a string. You'll notice that string is the most generic type of all. It really allows for sort of anything, whereas a parse error is really just a more specific case. So we might see, like, parse error has three cases where maybe there wasn't enough input, there was like the wrong character, or whatever else you might be able to think of there. So I'm going to start. I'm going to say myStore success, myStore. Okay, and I'm going to add a colon and a thing there. myStore. Cool. So again, feel free to ask any questions. I'm going to stop printing that at the end. So we'll print based on if it succeeded or failed. And I'm going to type in some crap. Got error, bash input, line 1, column 1, unexpected 1. And now I can actually make this parser a little bit more intricate. So I'm going to say my parser. Or actually, no, I'm going to not do that. I'm going to build the actual parser control flow of how this will all work. So I'm going to say my parser is a parsec. I'm not sure what it is. I guess this would be, well, I'm going to call it, I'm going to make it a card. So a card, card is a struct which combines all this data together. So I have my card number. This would be a character, list of characters. Just going to keep it really simple for now. Expiry date. And what's the last one? A CVC. CVC num. So now my parser is going to produce this card. And I'm going to run it as a part of this. And we will print the output to the terminal. How do I want to start with this? So I'm going to say, okay, so I want to start with finding the exe. And I don't need to do anything with that. So I'm going to toss out the information there. And now I have to deal with these spaces. So, okay, I wonder if there's a function that I can use for that. So I guess I'm in the package already. I know that I want to use parsec. Oh wait, no, sorry, I'm not in that. This is a different one. I am in the package already. Let me see if there's anything for space. Oh, cool. There's literally a function called space that I'm going to use, not to be confused with outer space. And I'm just going to do that. So this will, now at this point, I will have parsed myStore, and now I have the rest of the stuff. And the next thing I want to do is I want to parse the card num. I'm going to say card number, and I will run that parser. I will toss out another space. I want the expiry date next. So I'll say expiry date. I'll have another space. And then I will have the CVC. The names are starting to get a little bit overlapping, so I'm just going to do a little prime here. I could even call this like CVC underscore. That might look a little bit more familiar. And yeah, so that will parse all of that. And so now what I want to do is I want to finally produce this card. So yeah, so now all I do is I just am going to put this together. So I have the CNUM, I have the X for expiry, and CVC underscore, and that produces a card. And this should... No instance for show card. Okay, so this is saying that I tried to run your code and everything looks good, but the one thing is when I get to here in my simulation of your program, I realize that the output is going to be of the type card. And this is like, first off, I think it's so cool that like the compiler is able to even like deduce all this on its own. I haven't specified that this is a card ever. Like at least here, I've not put that output is a card, and then it's going, well, if this is a card, I can't show it because you never told me how to show it. But I've never even said that what this is a card, but it can deduce based on my parser and based on parse using my parser that the output of it will be the output will be of the type card. And that just helps me think about my program with less actual thinking. I've been able to just focus on how to write my parser, and this is, figured out that I have an error in my code, which is going to catch immediately. And so this is really easy to do for show. So show, no, when it says no instance for show card arising from use of show, what this means in plain English is that you have not defined the instance of the class for this type card, the class being show. And how it knows that is because you're trying to use a function from that class, show. I can show this really quick, no pun intended. If I go to Google and I search for show, what I'm going to find is that this is a part of a type class. So I see, so I have this class show A, and I have in this class, this is the only one I ever actually use, is show, which takes something that has this instance and turns it into a string. And this also shows me that I can do this show instance for any of these different types. So for example, I can take a show int, or sorry, I can show I'm not going to load the terminal here, but I could say show 1, and I think I already did that, and it will turn it into a string. So I'm going to try, I'm going to be able to do this now by telling it that I wanted to create this class instance for me, which is also cool. I don't even have to write the code. The Haskell program is intelligent enough to figure out how to write that code for me. Fair enough. Okay. I am starting. Now I want to say my store. And so let's try again my store. And this is going to say it failed because it was expecting a space. Okay. Fair enough. What if I say my store with the space after? It's going to say now expecting digit. And you can see that it's just continuing to expect the next piece. So if I say my store 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 0 6 2 9 1 2 3 success. You can see that it printed out the card number, it printed out the details of the card, which, in actual real world design, we wouldn't necessarily want to have a show instance for a card because we wouldn't ever want to be logging credit card information. But here, it shows us that we have done this successfully. Yeah.
All right, so that's great. We've got a card, but can I buy anything with it?
No, but I can add something to do that. So now, if I want to say, okay, so I'm looking at this code. Maybe even some idiot named Galen wrote this code, and I'm like, or I guess he's not an idiot because he knows Haskell, biased based there, but I want to add in the ability to buy an item. So Kyle, what are my requirements for the next?
So we
version?
sell. So there's 3 types of clothing that we sell. We sell shirts, pants, and shoes.
Shirts, pants, or shoes. Okay, so shirts, pants, shoes. I was gonna put singular for both pants and shoes, but that just seems weird. I don't think you'd buy one shoe. Okay, so cool. So now this is gonna be really simple to think about. How do I start this next? Well, at my top level function here, I am going to, before I parse the credit card information, I am going to and after the exe, I'm going to parse the item. So I'm going to somehow, and this is pseudocode at the moment, but it's going to be valid. I'm going to parse what the item is, or purchase
Store item.
Store item. Yes, thank you, sir. So now, how do I parse a store item? So I'm going to do this crappy, and then I'm going to do this pretty. So store item is also, I'm going to say, of the type parsec string. We're just going to keep everything as a string for now, and I am going to, well, gee, this gets complicated because now I have 3. I joke that's well, it's complicated depending on. I'm familiar with it, so it's not complicated anymore. But I know that I can parse one of 3 things here. So I'm either going to parse a shirt, a shirt, a pants, or shoes. Okay. How can I do this? Well, there's this. I'll save the time of how I would get to here, but there's a function called. It's basically option. So this looks maybe a little confusing, but ultimately what this is saying is if this fails, this action fails, retry this one. So if we were to take this and kind of boil down into what it actually is in our context, because I don't really care what I don't care for how general this is. So this is gonna fit parsec. This F is gonna fit parsec, and we'll get into a later date at why that is. But But ultimately, again, you could think of it as if I made another function, or sorry, another similar thing to parsec called like parsec with three C's, it would also work. So long as all three of these are the same. So now I can say, well, I know, so I know that if it was just shirt, that it would look something like this. I know that if it was just shoes, it would look like this. And I know that if it was just let's see here, pants, that it would look like this. And maybe I like wrote individual functions for shirt, for shoes, for pants, just like I did for exe and a similar. And let's forget about this one here because I don't know how to deal with three necessarily. But I can use this function alternative to say if this fails, if shirt fails, if you don't find shirt, try and parse shoes. And ultimately, what happens too is that if we like, this is kind of getting a little bit more into the types here or whatever. And if you don't understand this, again, that is totally fine. But what this ends up being is that we have this. I'll put brackets here. This becomes a parsec string, and so if we fit, can we fit this in? Yes, we can. We can fit this first expression here as this part here of using this alternative function again. So I can literally just say string pants, and this will work. And I'm going to format it like that just because I want to. And so now, ultimately, what this is saying is, and Kyle would be able to read this too very, very easily, even if he had never seen this code before, is try and parse a string of shirt, and then if that fails, try and parse a string of shoes, and then try and parse a string of pants. And now this is a bit of a technical detail here, but I'm just going to also put this here, just because of this is particular to the parsec library. But this is just going to make it more safe. And yeah, so it's just this is just a way of backtracking. If like let's say it gets to like shirt and shoes both start with the same sh, and then like if it was to get to like I or something, it would fail and it would have trouble backtracking. So this just helps it backtrack regardless of that. And so actually, this should work now, come to think of it, as long as I get rid of that. Yeah, perfect. I'm going to say myStore. I'm going to try and buy a shirt. And honestly, I'm lazy, so I'm just going to copy that and then paste that here. Oh, and I forgot to add a space in between here. That's why that failed. Cool. And I don't actually do anything with the item. So what I'm going to do is I'm going to use a tuple for now to just say item and card. And I'm getting a little bit ahead of myself here because this is technically item is just right now a string that I'm getting here. I want to return it here as that. So also too, I'll show an issue here. Let's say I change my type signature here. So I say that this this returns an item and a card, and I run this. This is going to fail because the compiler is intelligent enough to know. Well, there's two things actually. Let me just do this even. There's two issues, but this is going to say. I'm just going to simplify this here. Oh, this is even further simplifiable. So this is expecting, based on my type signature, that I give it a string and a card as a tuple. But I've actually just given it a card. And so the compiler is intelligent enough to know that I have not written my code in the way that I intended. And so now if I was to say item and fix my code, fix the logic in my code, this is going to work. This is going to compile, and I can now run with it. And so let me try parsing that again. So I can see that it's now giving me back a tuple of shirt and card. And I can do the same with also the other two. So I'm going to say, what is it, shoes. Shoes also works great. And pants. But if I was to give it, let's say, just to drill this home, pants with an S, it's going to say, I don't know what that is. And yeah, and I haven't done anything to make this error a little bit more user-friendly, which I could do if I wanted to, but I don't care to yet. That hasn't been part of the requirements, and Kyle, the businessman, has told me that I need this done for tomorrow. So now what I want to do is I want to make this, I want to typify this because I'll wait on typifying these parts, but I think this is a great example here with this string. So like here, for the user, I'm failing on pants with an extra S. So like, in the same sense, why would I want to have the possibility in my program that it's not pants with one S, it's pants with two S? Because I could have a function in the future which is going to read in, like, where do they buy? It's gonna go to inventory and try to look for the item that they've asked for. And so if I say like look up, let's say I was like saying like look up inventory. I had a function look up inventory, and I have said pants. This will work, but if I say pants, it's gonna go and have this error, panic, do not know. So that seems kind of silly that we're not allowing the user to fail, but we're allowing ourselves to fail. And so I am going to turn this into a very simple type called purchase item. So purchase item has three cases, which we've already talked about, which is shoes, shirts, pants. So now I'm going to change this so that this is going to give me back a purchase item. Now, I haven't fixed the code yet, but now I know that this can't just be any string. I know that it has to be one of these three cases. And you might look at this and say, like, well, like, what's the difference between, like for example, pants and pants? But it's what we just talked about with we know that it's pants, not pants S, because there's a million ways we can mess up there, and ultimately what we would mean is just pants. Yeah, and now, and also too, like I've noticed it's harder to like even something like this sort of type is such a basic thing of Haskell, and it can be very challenging to do in particular languages that are trying to become more like Haskell. So now, how do I make this actually work properly? I need to go down to this level, and I need to change from string to purchase item, and then now I need to fix my code so that it is a purchase item. And so I'm going to use a function. What is it? I'm going to use this function here. So you guys wouldn't have any familiarity with this function, of course, because you're new to Haskell, but I'll show you what it does in a second. It might intuitively make sense, but this is kind of it's very similar to this sort of like generic function, which allows us to just like you know repeat use like it allows us to use this in a number of different cases, such as parsec, and I'll show you in context of parsec. So we have this here. This is the function I'm using. And what is this doing? If we were to look at the documentation for it, it would say that basically just take this A and replace this B in the context of F. So what does that mean? We can get rid of that. It's a very dumb, straightforward function, right? So if I have, let's say, well, here I have shirt, and I have, right, a string of shirt. This is just going to destroy the shirt, or sorry, oh, I was wondering why that. Okay, destroy the string, and go and give shirt. So it'll go from a parsec wrapping of shirt to a parsec wrapping of shirt. And that's all we're doing here. And this allows us to make our code type safe. And with minimal effort, I should say. So shoes. Just going to wrap all that. And pants. All of my brackets are proper. I think this should work. Oh, parse error. I do have something. Oh, okay, there we go. Just forgot a bracket. No instance for show purchase item. That is fair because we have never derived it. So I'm just going to add deriving show like we did for card. Oh, okay. So pants is going to, again, fail. Pants is going to succeed, and we can see that we converted it into pants. So, Kyle, what's the next piece?
I was muted. Sorry about that.
All good.
So we need to know the size and the color for each of these items.
Okay, so maybe by now, and don't fret if you don't. You're kind of starting to get the pattern, even though like and if you're not getting the pattern, you're probably reasonably under kind of looking around at all the different pieces that are unfamiliar, and feeling overwhelmed. But once I can assure that once you would have like the basics of Haskell understood, like you would know how to make a data type, like in these two ways, you would immediately start noticing the patterns of how you're coding, and it would be just so easy to continuously add on to a program, which is interesting because like anytime I've been adding on to a program in another language, I find that is the most challenging part. And I think even Kyle, you were saying that like, it's nice to code in a box by yourself, and I guess that's literally what I'm doing here. But once you start coding with other people's code, it's really challenging to work with it. So I want the format of this to be. Do we have this here? I guess I want this to look like. Sorry, Kyle. What was the features that we want to know about the shirts, pants, shoes?
We need the size and the color.
Size and
And
color.
shirts are sized from extra large, like using like shirt sizing. Like they need to have the correct sizing, and for shoes, we'll be using US shoe sizes.
Okay. Sorry. So okay, shirts, um, shirt sizing, um, shoes, shoe sizing. Okay. Um, what would be okay, so I guess
And
like
then pants, we have waist and length.
pants.
It's waist size and length.
Waist size and length. Okay, so this is starting to get like a little tricky here because now we have based on what you parse here, should determine what we want to do here. So that actually does get to be a little challenging. Um, However, we are going to figure this out. So the shirt sizing, I guess, would be a data type because I know that there's going to be a number of cases. So shirt sizing, I don't know. Let's say small, medium, large. Shoe sizing is going to be. And this is also just helping me think. By the way, this is why I'm starting here. Because Kyle, I think you're throwing a little bit of a curveball at me. I don't remember this part, but
It was there.
oh, okay, fair enough. I threw it at myself. Shoe sizing, I guess. Um, I'll just say like 1, 2, and 3.
Yeah.
And we know there's more, but for the sake of eliminating manual time here, pant sizing is so you said waist and
Yep.
like
Waist and length.
okay. I'm gonna say like so. I'm gonna say that there's two pieces here. There's waist sizing, and then there's I'm just gonna turn this into a type. Or actually, I guess I don't
No,
need
you
to.
could do it. You could do a discriminated union of those.
Yep. Wait, sorry. Discriminated union, like
Some type. Same thing.
you mean like? Sorry, this is what I was thinking of doing. Where it's
Oh, like a. Yeah, that's a discriminated union.
oh
Some
okay.
type, same thing.
Okay, so height, and so now I have to say what are okay. So waist sizing. To break this down further, because I just made that up. Waist sizing, I'll say
So like 28, 30, and 32 are our main selling sizes.
okay. 30 and 32. Okay. And height is which?
Uh, the same.
Oh, okay. So I'll say height 28, 30, height 32, and okay. So now, how do I want to do this? The best way to break this down would be to just break it down piece by piece or case by case. So I know that shirt, pants, and shoes are going to be each their own individual cases. Color is going to be a color is the same no matter what, right?
Yes. Yeah.
Great. Okay. Color. We're going to say that we have 3 colors, and that is red, blue, and green. Primary. Yeah. So yeah, so color we know is going to be whatever, and then size we know is going to be dependent on what we've seen here. So if it's shoes, let's write the parser for shoes here. I'm going to write it up here, just shoes, shoe size. Yes. And there's going to be a parsec parsec shoe sizing. And shoe size is going to be okay, so this will actually just be very similar to the original shirts, pants, shoes, because it's just really strings. So we want to say I'm going to look for a string of SM or a string of medium. And by the way, if you don't understand this yet, this is not important. All this is saying, this is like a bracket where it says like everything to the right, evaluate first. So like try this right side. Try string MD. And then
It's a short form for parentheses. Is what it
yes,
is.
exactly. Right. This is the exact same thing as saying that. And except it's a little bit more powerful, but in the way that we're using it here, it's that's all that really matters. Okay, and so now, same way, need to SM. This would be medium. And then this will be large. And so, again, just doing the exact same thing, parsing a string that matches this. And then if that happens, if this case happens, replace it with the typed shoe sizing. Wait, is this shirt sizing? Oh, I just said shirt sizing. Okay, well, whatever. This works for shirt size by just changing the name. So shirt size, shoe sizing is going to be the exact same. I'm even just going to copy this.
And the compiler would have told you that it's wrong, so
Right.
that's good.
So I'll say 3, 2, 1. Like a count. Oh, I just did insert mode. Okay. And this is going to be 1, 2, 3. And this is now actually shoe size. Easy peasy. Except I haven't fixed this yet. And again, yeah, compiler would tell me that was wrong. It would say you're giving me a shoe sizing, not a shirt sizing, or vice versa. And then lastly, pant sizing. So, well, pant sizing is a little bit different because we have a curveball, but ultimately it's going to be the same thing as this is going to be the same thing as shirt sizing and shoe sizing. So I'm going to copy this one more time, or paste one more time, because I've already copied. Oh, no, I haven't. And I'm going to rename this to waist size, height size, just to keep it consistent. And I'm admittedly lazy. Waist sizing. Fun fact: my name in the community is Lazy Lambda, which it just basically means a it's actually like a Haskell joke, and that it's a function. A lambda is a function, and then a lazy means that it evaluates only when it needs to, which is happening here, but we'll save the explanation of that for a later date. Yeah. Okay, so we have waist size, height size, and I just gotta fix this. So
These
waist
should be
size.
digits.
Sorry, digits. Oh, like
We want to make it easy for the user, so they're just going to type in
oh, okay,
28, 30, and 32, and it's the
cool.
same.
Yeah. So in theory, I could use digit here as well, like the digit function, but I want a very specific sequence of digits, so I might as well use string. Um, and it also means less copy or more copy paste. And this is going to be waist 28, waist 30, 32. This is also going to be the same, except instead, I could make this, I could refactor this a bit, but no real point here. More work to refactor than anything. So height 28. I'm sure we can see that the similarities between waist size and height size. All that's really different is what we're putting over it. But yeah, that would be more work than necessary. So height 30. Okay, height 32. So now that works for height size. And there is one more thing, which is that we know that waist size and height size are going to be used in tandem. So I'm just going to put a little mental block there. And how to find the pant size is that pant size is going to be returning a tuple of height sizing and waist sizing. Pant size. This is just it's gonna be very simple in that we're just kind of like basically figuring out our spaces, and so I am going to view it as like, let's say we get a 28 and a 32. This is what this is going to handle. This is or like when I say input, like this is the piece of the input that this function is meant to handle. And so I'm going to say that waist size is before height size. So let's see. I guess it would just simply be. Sorry, I said height size. Yeah, okay, so height size. I'm going to have a space. And then a waist, which is going to be the waist size. And by the way, if you're wondering what these arrows do, they basically on the right side we have our parsec. So like here, for example, we have a parsec height sizing. This just rips it out of its wrapper into just being a height sizing. And so that's why I'm able to, at the end, do something like this, where I say pure H and W. And pure is just, pure is the opposite in that it takes an A and is going to return it as a parsec A. And so that allows me to, and the reason for that is just it allows for control flow. And I'm using under the hood a lot of control flow to use something like string, for example. Yeah.
This concept, you might have heard it if you've heard of functional programming. This is what's known as monads. So a term that might seem a little scary at first, but it really just means that we're just operating on we're throwing away the structure and we're operating on what's inside of that structure. So we're just worrying about height sizing and waist sizing here. And then when we return it, it's going to go back to a parsec height sizing, weight sizing.
Yeah, exactly.
Which is really powerful. Takes a bit to kind of see the light with that, but it's very powerful.
And when Kyle says it's powerful, what like it's not doing actually all that much. I think we should very much clarify what is meant by powerful. It's powerful in that like we can use it for a number of different things. Like once I know how like the monad like functions work, I don't have to I don't have to change my thinking when I'm working in a different context. Like I can use this wrapper in a way that like, and when we're talking about like monad stuff, like we're really just saying that like it's a common interface to deal with this sort of wrapper, and we don't need to care about how to specifically unwrap parsec. Because we could do that. There's other monads where we could like show you how to unwrap them and then get that value, but you'd have to do that so much to combine values that basically they just came up with this generic idea of a monad, which just allows us to basically ignore the context in order to do stuff. Like if I have, let's say I had like parsec int and a parsec int, and I want to return a parsec int. And there's an example from Golang, which I'll share in a second. Kyle, if I don't remember to share it, then remind me, please. If we want to, so there's two cases here. If we have like int, and this is just like add. So we want to do addition. So if I want to say 1 plus 1, this is really simple. It's just going to give me back, in the REPL, it's going to say 2. But if I want to do this with the parsec, then I have to say, x from like wrapped x. I have to say y from wrapped y, and then I can purely say pure x plus y. So it's just basically saying, like, I don't care what is wrapping it. I just want to do addition, and that's all we need to know about it. There's nothing. I don't think there's anything truly actually scary about it or whatever. I think people in the functional programming community are obsessed with it because it's so cool. But yeah, it's simple.
It's a lot easier than it's made up to be.
Yeah,
it's basically what we're trying to get at.
Yeah, we basically told you all the information you need to know about monads, even right there. But
yeah, a lot of people in object oriented will kind of say, "Oh, functional programmers, like the monads are so like why would you ever use them?" But like this is why you would use them.
Yeah, and even like an example is like in Golang, I'm working with a blockchain, and there's a coin, a coin object, and it's really annoying because all I want to do is literally I want to add two coins together. That's literally exactly what I'm trying to do. But after like a ton of like trial and error, I like look in the documentation and it turns out you need to say like coin, coin 1 dot add coin, and then it's like coin 2, and that's the only way to add these two coins together, and you'll end up with, some new value. And so it's just like instead of having to look up the documentation a billion times over on how to deal with coin or some sort of similar data structure, we just have a monad that we can say, I know how to ignore the monad, how to ignore this wrapper. So
yep. Sorry for the tangent, but yeah.
All good. No, all good. So that's pant size. We have our shirt size, pant size, shoe size. And now what we want to do is if we go back to we're going to add this back in here. And we, in some way, we want to add a space. In some way, we want to parse based on this item. So this does get a little bit complicated, but ultimately, what we should do here, the best way to go about this is to say, where's our items? I'm gonna maybe even clean this up a bit. Gonna move this up here. So, I'm gonna say full item, and this is gonna this is either gonna be shoes prime with a shoe sizing.
Just a question. Could you add it to purchase item?
I could, yeah, I could. Well, the only issue then is that like I have to return this from store item, but I haven't got that information yet. So I kind of need like an intermediate type to keep this nice and clean. So I'm just gonna also do this. So I have shirt prime, which is going to take a shirt sizing, and I am going to take a pants prime, which is going to take a waist sizing and a height sizing. Okay, and now this full item I know represents the fully parsed thing from what we were doing here. So I'm also just going to add show here. And right, so we know everything. This is all the information about what the user intends to buy. And so now this is going to be full item, and we are going to we're going to do. How should we do this? Yeah, I guess we should do that here. Parse full item with item as input. So this is going to be a parser that is dependent on the previous item. Parse full item. So my type is going to look like this, where I have a. Do we call it an item? We just did.
It was purchase item.
Purchase item. Yeah. Okay. So it takes this purchase item, takes as input a purchase item, and is going to return it as a parsec full item based on what we got as input. And part of the reason I need to do this, by the way, is because of purity. There might be another way I can do this, but this is the first kind of way I think to do it. So purchase item name, I'll call it. So case item name of, let's see, our three options are shoes. Just going to put this for now. Shirt. What was the last one? Shoe, shirt, and pants. Okay. So I this is the so like this is getting a bit challenging, I will say, because like what we need to know here is that all of these three underscores, like all these three areas, need to return the same type. So I can't have, I can't have like, let's say for example, like pure one, pure some string, and pure, um, pure true. That will not work because this is, well, it's expecting a full item, um, but um, because these are all different types. Even if I was to change this to one of the types, like if I said int, it would say that makes sense for this piece, but what are these? Um,
Yeah, and so that's why those sum types are really beneficial, because we can now encode all these different variations of data as one type,
yeah.
right? So you might have used like an interface or an abstract class in the past, but discriminated unions or sum types are they're a better way to do it. I personally like them because you can pattern match on them. We won't get too much into that right now, but basically the compiler will force us to handle every case. Whereas like if you just had an interface, typically your interfaces are spread around, they're like spread out throughout your code base, and there's no way to ensure that you've implemented something for every interface.
Right.
So it's like a better version of interfaces is what we're seeing here.
And also too, yeah, and that's like codified to the compiler right here in that for every type of purchase item, we have to have a valid like way to parse into a full item. So, and even the pattern matching is actually like even what we're doing here, because we're just saying like,
Yep.
if you look at this case item name of shoes, shirt, pants, we look and we see that this is the full set here. So we know, and it would fail if, let's say, we try to get rid of that. So
Fails at compile time, which
Yeah.
that's great.
Yeah, so we know that this is a fully valid function as long as we can write the function, which is that's the really cool part. And so this actually, I'm actually overthinking this now that I think about it, because I've pretty
Yeah.
much done this already. Is I've said for shoes, all we're doing here is we say size. It's going to be shoe size, and that's it for at least for this case. So I'm going to say now, shoes is just takes the size, and that's right. Like that's, I mean, the compiler
it.
will tell me if I'm wrong,
That's
but
it.
like yeah, that
Yep.
seems like it should be more complicated, but it's like nope. Like that's it. Like even though it's really hard to think about like how to do this, it's actually when you start like this is where I especially love type signatures, because this like just it cools my brain down. I go from like how does this whole thing work to like how does this piece work? I know that all I care about is this. Like my focus is like refined on that. All I have to think about is how to handle all purchase items, and return a valid full item. And then I can then say, well, okay, if I had to handle all cases, how about I go through all the cases one by one? And you saw I literally went like, okay, what are all our cases? Shoes, we'll do something. Shirt, we'll do something. Pants, we'll do something. And I don't even have to think about that yet. I can just sort of work through the problem. And then I get to here with shoes, and I'm like, oh, like because I've broken down the problem into its constituent parts, which you have to do for any language and any sort of problem, and that's also something we're going to talk about more in the future. We're going to have more sessions that are focused on like generic problem solving. You're going to ultimately get to this point, but Haskell is sneaky good here, because it's like you've once you've broken down that problem, your code like follows that flow. Um,
Yeah.
and
Yeah. The
so
way I like to think is that Haskell gets easier to write as it gets bigger. Whereas like typically, in JavaScript, TypeScript, Python, even like C, C sharp, like your programs get more complex the more that you add to them. It gets harder and harder to do things. Whereas here you're seeing like we're now just kind of like stitching everything together.
yeah, and it's like so like. And the reason this even here is so simple, and maybe it's maybe like this is like still a little confusing, um, in terms of like what exactly the code is doing, but again, feel free to ask questions like if there's something that is confusing. But all we have to really think about here is like the control flow. We've said like what are the details of how shoe size works, which is really easy to think about. Like I guarantee that if I gave any of you guys the challenge of like parse just shoe size, you guys would be able to do it. Even if you don't know Haskell, like and it's not like you have to use Haskell for this or whatever, but it definitely makes it easier, um, especially when we get to the stitching it all together. Um, but yeah, it just allows it to keep the problem and the problem space always very straightforward and simple. Um, and of course, it is hard to start with like myStore and like have this whole thing in your head. And how do we do this? That is complicated for sure at first, but that's like going to be complicated no matter what, regardless of what language you're using. But the point being that Haskell just flows very nicely from breaking down the problem to writing the code. And maybe if there's any pattern I hope you're seeing here is that I'm I don't need to start by creating an object which is like supposed to have these functions which parse properly or whatever, um, and I have to think about the control flow that way. I can just say like forget the control flow. I'm going to break this down first. I'm going to just do this, and then 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 once you've done all the constituent pieces, stitching the pieces together is all you have to focus on, and we're seeing how easy it is to stitch the pieces together, and further, because of the compiler, because of even just the way we're going about things, that we're tackling tiny little problems to start with. Like we're going to, I like mark my words. Like this is gonna work on the first try because I might be eating my words, but I don't like. I mean, the compiler's gonna work, and then this is
It'll
gonna
work.
work. Yeah, it's gonna work. Because it just we've solved the problem. We've done the thinking, and Haskell has just really helped us to guide us along that thinking. Um, anyways, um, you can tell we're obsessed with Haskell, but
Well, the thing is, I think the important thing is to explain here is that like this doesn't get any harder. Like it doesn't really
yeah,
get any harder than this. Like this
yeah,
is obviously a very simple, like we say it's complex, but it's actually a very quite a simple problem to solve, right? Like, but like it doesn't get any more complex than this. Like this is how you write your code. This is how you will always write your code, even if you're like, solving like a space simulation or something like that. Like it's going to be the exact same flow for writing your code. And the more you break it down like this into specific types that model what you're trying to do, it just becomes so much easier to sequence things together. And like I said, it becomes easier the more you write.
yeah,
Like the more code you add, the easier you're making it for yourself.
yeah, totally. And also too, it's just in terms of the actual code here. So I have pant size, which I'm going to use as a parser, and then I'm going to do actually pattern matching on the tuple, so I can get the height size and the waist size, and then just do pants and convert. I'm just converting this tuple really into this full item, so it's going to be waist sizing and then height sizing. Okay, and I had those reversed, but it doesn't. really matter. As long as I can type. I guess I'm finding that my fingers are more tired than my brain, but height sizing. Oh, because I just called it height. Right. So I just had, typos really. Compiler, help me with that. Deriving. Oh yeah, I got to derive show for all of these. I haven't seen this error yet, but if I'm having that, we're going to be printing out whatever, so I'm going to need to derive show for whatever, and I could go through one by one and show you guys that, but for the sake of speed, I'm just going to do all the deriving of show. Cool. Okay, so myStore. What is the format of input that we have? It's myStore shirt. I put a shirt size. Shirt size is going to be small. Oh, did we even do color yet, though? I don't think we did.
No,
Okay,
it's
well,
fine. For sake of time, don't worry about the color.
is
It's the
that
same thing. It's just another argument.
totally? So that's that many digits. 0629123. Cool, that worked. I wasn't even honestly sure that was going to work, but that did work. Oh, and we're not actually printing out what the size was. Oh, that's because we have the full item here. So now instead, this is our like main parser, right? We are now just going to say full item. That's fair. Oh, and that's fair because I changed it from just a purchase item to a full item. And the code is helping me update my code. And honestly, that's where I noticed that updating. That's where I noticed that the compiler is the nicest is when you're updating code and you change one value. You'll find that like somewhere way off in your code, which is depending on that code, would break in another language because of the change of type. Um, but here it's intelligent enough to fail and tell you that you need to update your other code. Okay, so shirt small. And yeah, so we have a command line store, which and I could do the other shirt. We have shoes. What's the shoe size? 1. Okay, let's try pant size. Pants. Was it pants or pant? No, it wouldn't be pant. What am I saying? Um, be so two. So let's say 28 and 32. That works. Um, and let's try to make it fail. Let's say I want to find 31. Nope, it failed. So that error is a little bit confusing, but we could handle that a little bit better. And there's actually very nice functions in parsec to help with that. Like for example, what's it called? Like it's literally um, parser fail. Is it? or there's like an annotate function somewhere. I want to see if I can find it quick. This wasn't like the plan, but um, I think it's like isn't. Yeah, there it is. So yeah, you can label. So I could say like label card number um, with card number, and then I think this will even. I want to try this. I haven't done this before, but so I've been too lazy. But card number. Oh, okay. Well, maybe if I fail on, or let me try this with. So what I'm expecting to happen here, I've never used this before. I've just known about it, and I've been too lazy to care about it in my own work. Um, but this, what I believe will happen is if this parse full item fails at any point, like so, it could fail on waist size, it could fail on shirt size, it could fail on parsing the full item. I just don't care where that is. I could maybe get more fine grained with it, but I just want to fail like that. Oh, okay, no. So I'm not sure exactly what that does, but um, hmm,
That's what happens when you try to do something new in a demo.
that's fair. Yeah, yeah.
but
So
but yeah, I think that's good.
yeah, I was trying to show some like parsing control or whatever, but yeah, no, that's I think that wraps it up, right? I mean, I think we had more, but it was like at this point, like not really. I don't think it's worth getting into the other ideas
Yeah,
we
we don't
had.
need to, but basically one of the things to note here is like you might be wondering like what if the order of these arguments changes? Um, like we can actually to some degree control that, and you can have specific like options like I we encourage you to take a look at parsec if you are curious, because there's a lot that you can do with it. Like right now everything's very sequential, but you don't have to go like one by one by one by one. You can do different branchings, you can do
Yeah,
optionals and all this kind of thing, which truly does make it more powerful than regex.
yeah,
Whereas like in order to do that stuff in regex, like you've got like a 2 page long, like if you just go take a look at the regular expression for emails, and it's like 3 pages long. Nobody ever will ever understand that. Whereas like if you were to do that in parsec, it'd be quite straightforward. So
yeah. I was gonna try and do it while you were talking. Um, let's say okay, so let's say we have we're gonna like I think we get the idea that we can do different like options there.
mhm.
String. So let's pretend we only have one color of red. Um, we could change this so that we um, I guess we would need to apply to each of these individual cases. I'll just show it for shoes, and then we would do the same for these other branches. But we'd have a space to include our color, um, and then we would parse color. So let's do that. We're not going to return the color because we haven't updated our types. But like so that's like case one. So I'm gonna even just like copy this out and call it case one. Lazily, no pun intended, I guess. And this is going to be case one is a parsec full item. But then also so and then I guess case one and the other case would be case two. I am going to comment that out. Um, there we go. Case 2 is also a parsec full item. and we would just say we would just write how that would look. So first we'd have our parse color. We'd have our space, and we'd have our size. And we could compress this code a bit, but like I think it's better to demo like this. Um, we could make this like much cuter. So I'm
Yeah,
just,
this code is very verbose, by the way. Like, if you really want to get into like Haskell will allow us to reduce this by a lot.
yeah.
But we're just showing it.
I could
It's
do
easier.
it. Yeah.
We could do it. We could throw in a bunch of operators and a bunch of like really confusing things to make this into like
One line.
yeah, one line. But then you'd be like, what the heck is going on?
Right.
So yeah, just
Yeah.
a side point.
Yeah. So and this would literally be how we do it. Is we just check if colors first. Um, or like we try case one first. It's gonna look for shoe size. And then color. And so like let's say that the input is red, and then it is our shoe size, which was like 1. Oh, that's actually a movie. Uh, but then it's going to fail on case 1, and it's just going to say, okay, try case 2, and then this input is going to succeed because it's going to try then parsing the color, and then try parsing the shoe size. And again, we can apply this to other cases. And yeah, and the key thing being, like, we did all that. We changed up how parseful item works, but notice that, like, this code is right from the beginning. Like, we haven't changed anything about any of this. We've changed our main function, right? I mean, our main parser even. We haven't touched main, but we have touched my parser to change it up and add more features to it. And we just added more features. That's all we've done. The entire last bit has been about adding new features as opposed to trying to add new features and then adding bugs. So, yeah. Kyle, is there anything else we're missing, or?
Nope. I think in terms of time's sake,
Yes.
I think that's good. Yeah.
Cool.
Yeah, we haven't had any questions or anything. We'll be uploading this to what it'll be, probably Vidyard or something. I don't know. And
Cool.
then it'll be there for reference.
All right, sounds good.
So I think right now everyone else had to drop a bit early. Hector, do you have any questions? I think you were typing, right?
No questions from me. For now, no questions. Maybe subsequently I might have some questions when I go and look back at.
Yeah, awesome.
Yeah, totally.
So we have some like training. We have some projects set up to get started. Basically, the goal is like once you finish those projects, we'll review it and we'll like give you a badge, and then like based on the badge that you have, we've got a talent pool right now that's looking for this kind of talent, and so we can like directly vouch for you, and like that. I think that'll do a really good job because like sometimes the hardest part of finding a job is like having someone to vouch for you. Like I know pretty much every job that I've gotten has been because someone says like this guy's good.
Yeah.
Like just honestly, because there's so many people that are trying to get jobs and there's not really good ways of like determining their skill level. And so yeah, if you want to give this a shot, try working on some projects, reach out to us with any questions, and then yeah, hopefully we can help you find your job, find a good job. And even if it's not in Haskell, like these skills are very valuable in other languages. It's going to turn you into like a champion. People will either love you, like your fellow developers might not love you, but the person hiring you will love you.
Well,
because you're always they'll love you eventually, but I've had like what I mean by that is like you're gonna be looking at all of these cases with a lot more scrutiny, which will make you a much better developer. So that's at least the goal.
you'll know what good code looks like, kind of thing.
Yeah, yeah. Okay, so yeah, I think that wraps us up. To anyone who's watching this offline, you can find all of the training materials on the ACE Talent platform. If you need to sign up, there's a sign up link through the landing page. And yeah, we hope to talk to you again in the future.
All right, bye.
Cool. Take care.
Let's see ya.
Yeah, bye.
Bye.
Bye. Oh, yo. Okay, here.
I'm gonna end the call or end the recording.